Welcome to our program, Astronomy for Everyone. With me here in the studio this evening is Mike Bruno, a member of the Ford Amateur Astronomy Club. Mike, welcome to the show.
Thanks, Don.
Now, you're going to tell us today about the scale of the solar system. What's up with that?
Well, I've always been interested in astronomy, and when you're looking up at the sky, you see these bright dots, and you see the planets through your telescope or whatever. And I've always been fascinated with, like, well, how big are these things? You hear how big everything is, and how far away it is. So I did some research, and I put together a little scale model of the solar system here that I like to present for public outreach. And so I like to start off with, asking you, like, have you ever held the Earth in the palm of your hand before?
Not really, no.
Well, hold out your hand, and I'm giving you the Earth. The Earth here is a blue marble. It's just over a ½ an inch. And for this scale, the Earth is compared to this weather balloon here, which is 5 feet in diameter. And this one little Earth right here, you would fit 1.3 million of these into that 5-foot weather balloon.
Wow, that's quite a few.
Yeah. The sun is actually 865,000 miles in diameter, and the Earth is 7,900. But at this scale, you would take that little Earth and you would go 550 feet away, and that's where you would set it. And that's how far we are away on the scale.
Based on the scale that you're showing us here.
Yes, and that is 93 million miles approximately in actual terms.
I see.
And now, if you happen to hop in your car and took the highway to the sun, you're doing 70, it'd take you over 150 years just to drive to the sun.
Wow.
In reality. So I really like to show the kids and various other people about this, and I have some other displays that we can talk about.
Great. Let's see them, Mike.
Okay. How the planets line up, Earth is not the first planet. We have Mercury. Mercury is 3,000 miles in diameter, and it's 36 million miles away from the sun. But on the scale, it's only 0.2 inches, or just over 5 millimeters. And right here I have a peppercorn as an example for Mercury. So we would take that, and we'd go from this weather balloon, just 213 feet about away. And that's where we put this little peppercorn compared to the sun. And then moving on, the second planet from the sun is Venus. If you notice, Venus on this display is the same size as the Earth. I have a painted marble here, because Venus is almost the same size. It's 95% of the size of the Earth. It's 7,500 miles in diameter, and it's 67 million miles away from the sun. But on this scale, you have just over a ½ inch marble, and you would go 400 feet away with that marble. So now we went 200 feet, 400 feet, and then after that, of course, is us. So we have the Earth. We talked about that, but we also have the moon. And the moon is 2,160 miles in diameter. And on this scale, we have the moon here on actual scale. So I'll ask kids sometimes, like, how far do you think the moon is away on this scale? And people have given a variety of answers. Some people think the moon's the farthest humankind's ever traveled.
Right.
But on this scale, we've only traveled 17 inches, which is, I find, pretty fascinating when you really think about it.
Not far at all in terms of this scale.
Yeah, not far at all. But I just think it's something that it kind of brings you down into relative terms where you stand on the Earth,
Exactly.
Now something a little bit more, when I'm in this part, I kind of jump off a scale here real quick, and I talk about a globe, because a lot of people are familiar with the globe. And this is a common 9-inch globe that you would find in your home. And on this scale, I give the kids a tennis ball, so I get them a little active. And I say, okay, hold this tennis ball, how far away you think this is from this scale is. You have just over 2.5 inches would be the moon, and you would go 23 feet away. So now it gives them like, okay, now I see the Earth. Like you don't see the continents on that marble, but you get to see it. And some people will hold it like about here, you know, and some people will go out, walk a distance, but they're kind of in awe. They've never made it to 23 feet yet.
They don't think it's that far
Right.
in terms of this relative scale.
But then I say, well, I give them one other question. How far away do you think the space shuttle is, or the space station on this scale? So when you take a look at this scale here, you'll get a variety of answers, of course. And I just love the answers from the kids. But basically, you can just hold your finger. You're about a half an inch above the globe. And that's how far our space station and the space shuttle average orbit is. It's 200 miles. It's approximately 200 miles above the Earth's surface. But on the globe scale, you're only a half an inch. And that's outer space where we are right now.
That's fascinating, Mike. I wouldn't have thought it would have been that close. I'd have guessed out to here, maybe 3
Right.
inches or so.
It doesn't take much to free fall around the Earth.
No, it doesn't.
No. But then moving on, we have one other terrestrial planet, Mars.
Mm-hmm.
And here we have Mars on this scale. It's represented by a pellet. Mars is actually just over 4,200 miles in diameter. And on the distance-wise, it's 142 million miles away. These are all average distances
Right.
from the sun. But this pellet here is only 0.3 inches. And on our scale, though, we're moving from Earth, which was 550 feet, out 838 feet.
Wow.
Yeah. But in between there, there's a big space. There's the asteroid belt. And just a quick point, the asteroids, there's over 1 million of them out there. And we know the asteroids may have taken care of the dinosaurs for us. But of those 1 million asteroids, the largest one's 25% of the entire mass of all the asteroid belt if you just vacuum them up. And then you would have only some mass which is quite small even compared to the moon. The moon's a lot larger. If you chop that up into asteroids, the mass of that is entirely a larger number.
So it's just the asteroid belt just because it's spread out over such a large area.
It's spread out over a large area, yes, but
I
that's
see.
in between. So, so that takes care of our terrestrial planets.
Where do we move to next, Mike?
Well, the next planet out is Jupiter. Jupiter is 89,000 miles in diameter, and this scale, it's a kid's ball. This is like a number 2 soccer ball. It's 6.3 inches, so now you can hold Jupiter.
Interesting.
Yeah, and on this scale, Jupiter would be a half a mile away from the weather balloon we have here.
Wow.
Yeah.
We've gone from 800 and some
Yeah.
feet to starting to measure it in miles now.
Yeah, now we're into miles, and this is just a 5-foot weather balloon we have here.
Oh my.
Yeah. Also, we move on after Jupiter out to Saturn. So I have Saturn here represented by a toy basketball. And Saturn is actually about 76,000 miles in diameter. This scale, Saturn, the planet, is 5.3 inches. And that's just a little kid's toy basketball. But as you notice, we have the rings.
Mm-hmm.
And yeah, the rings really add to the diameter of Saturn. They're 175,000 miles in diameter from one end to the other. And the rings are really just about 1 kilometer or just over a half mile in thickness.
Right, they're not very thick at all.
Not at all. So, but if I tried to make the rings to scale, I'd have a piece of tissue paper here. So I kind of cheated a little with some cardboard.
We'd have a hard time trying to
represent
hold it and represent
Yeah.
it.
But then as you can see also, Jupiter is much larger than Saturn, but then when you hold it in front, the rings outdo
the distance of Jupiter by a
exactly.
good margin.
They do, yep. But we'd have to take Saturn now 1 mile away from the weather balloon and place this right here 1 mile away from our 5-foot weather balloon that we have here. And I just find like that's kind of interesting. You can get in your car, you could walk a mile, and then there you are. You're just with this little 5.3 inch ball. But then moving on, we have another gas giant planet. Now, when I did the research and I put the scale together, I didn't realize myself that they call them gas giants, but when you're talking about Uranus, Uranus is a gas giant. But on this scale here, Uranus, which is actually 32,000 miles in diameter, is only 2.25, 2¼ inches, the size of a racquetball that I have here.
Mm-hmm. And yet it is 4 times larger than the Earth.
It is. Yes, it is. And this planet is 1.8 billion miles from the sun. But on our scale, we went from a half mile to a mile. Mm-hmm. Now we go 1 more mile for a total of 2 miles just to get to Uranus. And then we move on to another planet that is similar to Uranus in size, is Neptune. Neptune is 31,000 miles, so just a tad smaller than Uranus, but it's 2.2 billion miles away. So I represented it again with another racquetball, 2¼ inches. But now we went, half mile, a mile, 2 miles. What do you think the next guess is here?
I'll say 3 miles.
You're right, just over 3 miles. Just over 3 miles, you'll find Neptune. And on this scale, now it's getting long. It's really for these little objects to go that far away, but to see this 5-foot balloon, it's fascinating.
It is. It truly is. When you stop and think about it in those terms, it makes it seem much more real when you're talking about the miles, billions of miles. It's kind of tough to get your head around that, but this scale really does bring it down to more terms that I think people can get their head around. Mm-hmm. We have a couple of other items here with us in the studio, Mike.
We do.
Tell us about those.
I don't want to pass up on one thing that was demoted recently, was Pluto.
Indeed.
Yeah. Pluto, when I prepared this presentation, was still considered a planet. Now they call it a dwarf planet. Whatever. To me, it's a planet. Let the academics decide what it is. But it's a hard object to see even on this scale. But Pluto is only 1,400 miles in diameter. It's smaller than our moon, and it's 3.7 billion miles away. On the scale, though, how far do you think? Half mile, mile, 2 miles, 3 miles? Pluto?
Let's go for 4.
You're right. 4.1 miles about is on this scale. A little tiny BB that you can barely hold on to, and that's Pluto. And we're sending a probe there that should get there around 2015, I believe.
I believe so, yep.
Yeah.
Yep.
But then moving on, though, there is something that's not a planet, but it's farther away than everything here. And it was a probe that was launched in 1977, and it's called Voyager 1.
Indeed.
Yep.
Yes.
Voyager 1, I don't have a scale represented on this because it would probably be a dust size. But the distance-wise, right now, Voyager is 10.7 billion miles away. So that's about 3 times farther than Pluto, just about. And that's the farthest anything has ever been sent from mankind out there. But on the scale, it's 12 miles away. So we went, so that's about 3 times Pluto. And so that little probe is still cruising on to infinity, but right now it's 12 miles away. Moving on, though, I have another item, is a basketball. Do you have any idea what this might be?
Besides a basketball?
Yeah.
No, I don't, Mike.
Well, I like to tell everybody this is another star. And this is our next closest star to our solar system.
Indeed.
Yes, this is Proxima Centauri. Proxima Centauri here is about a 9-inch basketball. And on this scale, which we would have to take the space shuttle or a rocket ship and go out 28,000 miles, which is farther than the next, the geostationary satellites are. and you would just drop this basketball off. So this is hard to imagine, but this is farther than the furthest satellites right now, and that's our next closest star, which is over 4 light years away.
Very interesting. All right.
Yeah.
All right.
And a lot of people have heard of Alpha Centauri too, and actually Alpha Centauri is it's a double star system.
Mm-hmm. Yeah, I think there's 3 altogether. It's a multiple star system.
Yeah, multiple star system. And Alpha Centauri is similar in size to our sun. This is a 5-foot weather balloon. I'd have to go out 1 more foot, and then we'd have Alpha Centauri. And then just another 1,000 miles in the spaceship, and that's where you would put Alpha Centauri. It's 29,000 miles away.
I see.
Yeah. So that's my scale of our solar system and our next closest neighbor. I also have another item that I like to talk about too, and it's the mass of our solar system. And this is just a quick overview, but what I have here is 30 pounds here of stones. And I usually have various measuring cups and spoons and stuff set out. And I ask somebody that comes up that's interested, they say, well, what's all these stones? And I tell them, well, this is, if we took all the mass, vacuumed it all up, the sun, the moon, the planets, the comets, the asteroids, this is what you get, 30 pounds of stones right here. And then I say, take a scoop and let me know, what do you think makes up the Earth or the solar system? So would you have any guess on 30 pounds of stones, how much would make up everything else except the sun? We have the sun and everything else.
I'd say this little piece right here.
That's probably a good representation of the Earth, actually. But what I have here is not even 1 ounce out of 30 pounds of stones. And if you hold your hand out, right here, compared to this, that is our entire solar system outside of the sun. So
wow.
You look at the sun and you know it's burning, some phenomenal amount of gas a minute, but it's not going to go out anytime soon. Especially when you look out here and you see this, and we have one little stone that, a real small stone that might be the Earth. Oh, losing some of the solar system, and then 95% of this is actually the 4 gas planets. So there's really not much left with the terrestrial planets, the comets, and the asteroids compared to the mass of the solar system here.
Wow. This is amazing, Mike. It's just to put it in concepts that you can hold in your hand and get your head around in terms of distances that we can really understand. It puts a whole new perspective on it.
Yes, I think so. And the comments and the remarks I get from, the kids and the parents and the oohs and the ahs, looking through a telescope, I just love to show a kid the moon for the first time through a telescope. It's just great. And presenting something different like this, the scale of the solar system too, it makes them think, wow, this is, you're kind of small when it comes down to it. So just imagine, we're just a blue marble in the whole scheme of things.
Mike, this has been a fascinating discussion. I'm glad you were able to come and share it here with us today. And if you have any questions you'd like to send us, don't forget about our email address. You can see that down at the bottom of your screen. And don't go away. We'll be right back after this.
The term of the month for February 2011 is Tropical Zodiac. Last month, Park Kunkel, an astronomy instructor, was interviewed by the Minneapolis Star-Tribune, and he said that all of the zodiac constellations had shifted, and so all the zodiac signs are wrong. It must have been a slow news day in Minneapolis because it made it all over the internet, and I'm talking about it now. So here's the deal. Your sun sign in astrology, and I'm not really into astrology, but these are definitions, I can deal with that. Your sun sign is the constellation that the sun is in on your birthday. So take an example. My birthday is in January, and it's late January, so that would make me an Aquarius. But I looked up my birthday, in a planetarium program and found the sun, and it's not in Aquarius, it's in Capricornus. So what's with that? Well, it turns out that astrology was put together 5,000 years ago. They were interested in where the sun was and what constellations it went through. And despite the fact that you really can't see the constellations that the sun is in, because the sun is up during the day and the glare of the sun washes them all out, they mapped the sky and they figured out where the sun really is, and they didn't get it wrong. But the Earth has something called precession of the equinoxes, and slowly it causes the constellations to shift. The Earth's axis goes around once in 26,000 years, and so we've had enough time for everything to shift by a constellation. It's not a new idea. Ptolemy talked about it 2,000 years ago, and he said there were other issues. There was a 13th constellation, Ophiuchus, that the sun went through. But he said that the zodiac signs were just convenient names for 12 30-degree segments that the sun goes through, so they're all the same length. There are, in fact, there are at least two, astrology camps, and we'll call it tropical astrology and sidereal astrology. In tropical astrology, they haven't changed what the dates are for the signs in a very long time. In sidereal astrology, they're interested in exactly where the sun is. The popular horoscopes you read in the newspaper and so on, they are written generally for tropical astrology. And so today's term of the month is tropical zodiac.
Welcome back. Coming up on Saturday, March 12th, is our 8th annual Astronomy Expo and Swap. And here to tell us a bit about it is John Schroer. John, what are some of the details of this exciting event?
Well, the 8th annual Astronomy Expo and Swap Meet is Saturday, March 12th. It's going to be at Holy Cross Lutheran Church. That's on West 6 Mile Road in Livonia, between Middle Belt and Merriman. The event features a series of presentations, including Dr. Karen Bjorkman from the University of Toledo. There'll also be workshops where people can bring in your telescopes that you're having trouble with, and there'll be people to help you learn how to make them work properly. There'll also be vendors there, such as Jeff Heinlein's Great Red Spot Astronomy Products, and people will have tables where they can sell used equipment like binoculars, telescopes, eyepieces. You can even join the Ford Club during the event, and you can pick up Ford Clubwear. We usually have a table usually manned by Bob Fitzgerald, and it has sweatshirts and T-shirts and the like, and there's a shot of Bob right there.
Now, we're going to have some educational component to this as too, right?
Yeah, there's a planetarium that will give tours of the night sky. There'll be programs to educate people on the different kinds of telescopes and binoculars, what to look for when they're shopping for them. And there'll also be people selling all kinds of observing aids and books and the like.
Now, where can our viewers get more information?
Well, they can always get the flyer once it's published, which should be sometime by the end of January, at the Ford Club website, which is at www.boonhill.net/FAAC.
Right, well, it sounds like an exciting program. I know in the years that I've been there, it's been a real treat to partake in this.
Yep, and it's not just adults. Whole families show up to partake.
That's great. Well, I want to thank you, John, for stopping in to tell us all about that. And right after this, we'll head to Term of the Month. Stay tuned.
What's up for February 2011? Well, the moon phases this month are more or less on Thursdays. It's new moon on the 3rd, it's first quarter on the 11th, it's full moon on the 18th, and last quarter on the 24th. Jupiter has been dominating the sky for months and months, and we're toward the tail end of that. Jupiter is an evening object. It's in the west just before sunset, And preceding it to set is the planet Uranus. At the beginning of the month, it's just 3 degrees ahead, or below, actually, Jupiter. And that's convenient for binoculars because you can get Jupiter and Uranus into one field of view, might make it an easy way to spot the planet Uranus. By the end of the month, Uranus has pulled ahead, and it's 8 degrees ahead of Jupiter. Then we have Saturn. At the beginning of the month, Saturn rises at 11 p.m. By the end of the month, it rises at 9 p.m., making it that much more convenient. The rings are tilting over, and so we're getting a better and better view of Saturn all the time. Saturn is a very small object. It gets to be 19 arc seconds. It's not very big, but here in February, it's 18 arc seconds, so it's almost as big as it gets. 19 arc seconds, by the way, happens in April. Saturn is just above Spica as it rises. It's just a few degrees above a very bright star. Venus is a morning object. It rises around 5 a.m. Now, it's best about an hour before sunrise, and the sun rises around 7:45 at the beginning of the month and 7:08 toward the end of the month. So somewhere between 6:45 and about 6 o'clock is the best time to look for Venus. And that's what's up in the night sky for February 2011.